Hi everyone. In this video, I'd like to show you how you can analyze your results on Comsol. When you get some results on Comsol, you can analyze them by exporting it to another software. For example, if you have calculated some electric field, electric potential, you can also calculate it using a formula. In this example, I'm going to take a typical spherical charge distribution, constant charge density, and you set this up in Comsol and you plotted, say, electric field as a function of distance from the center. Then you can also calculate this analytically and compare them. One way you can do that by exporting your data to another program, Excel, although I don't like it much, some data analysis software, Mathematica, Python, Igor Pro, something I use, and analyze it there. But you can also analyze it on Comsol directly. So that's what I would like to show you. So first, let's go over the problem. So I have constant charge density rho. It's a spherical charge distribution, and I want to calculate the electric field outside and inside. Okay, so if I do it outside, I take a Gaussian surface concentric with it, and a typical equation goes like this: E 4 pi r squared, charge enclosed. Since all the charge is enclosed, we can write 4/3 pi. Let's say if the radius of this sphere is a cubed, that's the volume, multiplied by charge density, that is the total charge enclosed when it is outside, which is r greater than a, divided by epsilon naught. So you see there's 4 pi's cancel, and then the electric field can be written as a vector outside rho a cube over 3 epsilon naught, right? Rho a cube over 3 epsilon naught, and then 1 over r squared, r hat. When it is inside, we're going to pick a Gaussian surface of radius r less than a. If it is less than a, only the charge within the Gaussian surface will be included. So the left-hand side will look similar, E 4 pi r squared. Right-hand side, then I need to take the volume of this, which is going to be 4/3 pi r cube multiplied by rho. Since it's constant, I'm not integrating, just merely multiplying with uniform charge density and the volume, and divided by epsilon naught. Here, 4 pi's cancel. R squared cancels with r cubed. I just have r here. So electric field inside would be rho over 3 epsilon naught times r hat. Okay, so I have these, so I can basically set these up in Comsol and then calculate electric field inside and outside, and include my analytical plots in the same graph with Comsol simulation plots. That's what I would like to show you. Okay, here's the simulation. Let me first show you. I defined the parameters that are relevant: epsilon naught, vacuum permittivity, radius a 1 centimeter, rho charge density 1 coulombs per cubic meter. And I use them in my geometry and in my boundary conditions. So for example, the charged sphere radius is defined by a. The enclosure is 10 times a radius, 10 times greater. Then in charge density, I have rho here that is used. All right, it shows the typical expected distribution. If you look at the potential here as a 3D plot, you see a high potential at the center and gets smaller as we go to the outer boundary. So I did a 1D plot group where I'm plotting electric field magnitude along x-axis. So x-axis serves as my distance from the center. In fact, maybe I should just change my x-axis label as distance from the center in centimeters. And then y-axis labels is electric field magnitude norm volts per meter. So let's say I want to analyze the data here. So I want to overlay the formulas that I have derived for the case where we are inside the charge sphere, 0 to 1 centimeter, and for the case when we are outside the charge sphere, when r is greater than 1 centimeter. So what you do is you take this 1D plot group. I might as well name it as electric field. And this is the actual electric field from Comsol. So I'm going to name this as Comsol result. Now I want to have analytical plot. So I can say, all right, right click, add another line graph to this plot group. I'm going to name that analytical inside. Okay. If you remember, inside, my electric field looked like rho over 3 epsilon naught times r. So what I'm going to do, instead of y-axis data here, I'm going to put an expression. And then I will use, okay, I have rho, okay, times r. That's the distance. In this case, it's x coordinate. But remember, I should do these in SI units. So I'm going to put it in x times 0.01 so that it is in meters. So I'm converting it to meters this way. And then I divide that by 3, and I divide that by epsilon 0. Okay. So let's plot these. Oh, the x-axis data, again, I want to do expression and my x coordinate because I did the cut line 3D. Let me show my cut line along the x-axis. It doesn't matter. You can do along y-axis, z-axis because it's perfectly symmetric, spherically symmetric. So any of them will work. But basically, that acts as your line that's drawn from the center radially outward. So if we go back to analytical inside, and this has the formula, and you plot that, okay? All right, now it's plotted, but you see it doesn't work, all right? I think I know what it does, why it doesn't work, because actually I don't need to convert to meters. That was my mistake, because all the rho epsilon naught, they are already defined in SI units. So, and Comsol knows that this is in centimeters, so it will do that automatically. So let me show that to you. So I'm going to delete that 0.01 multiplication with x to convert into meters. So just this, and then let's do that and plot it. See, for inside, now I have a perfect fit along this line. Now I also have outside, so I can do that too. But it's, okay, since I'm calculating it for the entire domain, 0 to 5 centimeters, it goes all the way to these large values, and I don't need that. So let me first change my limits. I go to the electric field plot group, manual access limits, I don't want my maximum y to go over 0.4 times 10 to the 9. So what I'm going to do is I will say 0.4 E9 and then plot. Yep, it is very good now. So this is the inside. So now I'm going to add the outside result. Let me see. I'll just say another line graph. And I'm going to name this analytical outside. Okay. Now, again, same deal. For the expression, I will write in my formula for the electric field outside. There I have rho times a cube. And then that's divided by 3 divided by epsilon 0 divided by r squared. Well, it's going to be x squared because x coordinate acts as my r distance from the center. Okay, so let's say plot. As you see, there's a very good fit, both inside and outside. So this way, you can actually analyze everything on Comsol without having to transfer to another software. I hope this is useful. And please let me know if you have any comments and suggestions.